having our topic starting of an induction motor. Starting of an induction motor. So my dear all, as you know, an induction motor cannot be started directly with supply, because during starting, as there is no relative motion within the rotor part of the induction motor, so it will simply draw very high starting current from the source. Induction motor, as you know well, it is a kind of a rotating transformer. So during starting, it is very important to think about the stator and rotor part of the induction motor, and as the rotor is standstill, and in the meantime if you give a direct supply to the stator, then the stator will draw very high starting current, which is harmful, and which is although the reason why, because we will be paying excessive money to electricity board. So to avoiding from that, it is very essential to introduce one starter, that is starting device, which is a protecting device, safety device before our induction motor, which can safely deliver the current towards the stator part of the induction motor. And starter, it is a starting device along with few safety protections are there, like when abnormal current will flow, overload will be there in the induction motor, it will simply give the braking command or off command or stop command to the motor. So through that way we can say the starter which can help the induction motor, through which the motor can start and run safely. So this is about the diagram where your induction motor, 3-phase induction motor, this what you can say DOL, direct online starter. There are varieties of starters are used before our induction motor. Based on the capacity of the machine, based on the size of the machine, we can choose, we can decide which type of starter is suitable for our motor. Like up to 5 HP, DOL starter normally recommended up to 5 HP, and above 5 HP to 20 HP, star delta starter is recommended, and from 20 HP to onwards, auto transformer starter is recommended. So today we will be having our discussion on DOL starter, that is direct online starter. So this is about our motor, which is having 3 terminals, and this is the power circuit of the starter, where you can find overload is there. All these 3 are the overloads, and this is the contactor. This part is the contactor coil. 3 fuses are there, and one switch, TPSP switch is there, based on which when we share our command to TPSP, supply comes, and through fuse it will come through overload relay, then it will come to the contactor coil. But the contactor coil will not itself gets on once, although we switched on the fuse our TPSP switch. To safely energize the contactor, one control circuit is mandatory, through which we can safely flow the current towards the contactor, and the contactor can energize, which can allow the current to flow and the motor can start safely. Now let me draw the control diagram of this starter. I will show you through one line diagram. The control part of this starter I will show you through one line diagram. Let's say this is your stop push button. Then start push button. Then this is the contactor. Let's say this one is base. neutral. So from this you can understand phase, then stop push button, start push button, then contactor. One coil of the contactor connected through start push button and the next one is connected with the neutral directly. But in this circuit up to this, if we press the start push button, current will flow through the contactor coil gets on, okay, and when you release, the contactor will be disconnected. So up to this part, what you can say, inching function, right? Up to this is inching function. Now to make this latching, okay. Now to make this circuit latching, one NO contact of this contactor coil, they are to place parallelly with the start push button, and here you can mention NO of K. So in this case, when you press the start push button, the contact coil will be latching in condition and the supply will throughout it is going towards our motor through the contactor. In case during operation, in case there is any overload or short circuit or any abnormalities is there, overloads are there. Overload can give, these are all three thermal overload kind of relay. Okay, this thermal overload relay will help to treat the signal. Which signal will cut off the contactor coil and contactor coil will disconnect the motor from the source. So through that way, we can save our motor from overload. We can also save our motor from abnormal voltage, and fuses are there. Along with this overload relay, the fuse can also give the protection to our 3-phase induction motor. Okay. So in our next class, we'll be studying about our star delta starter. When the capacity of the induction motor it will be raised, then how we can go for to start the induction motor safely. Okay. So thank you all.